That's good. You can have to do the other side way, so the cat is going that way. Stick operation. Well, my guys, just now? Your eyeliner? But it's a little smooth. Yeah.
Hey, Bella.
Like, I don't even know I still have this. So funny. It's like, who are you? I think I'm supposed to like that.
Okay, a couple others are here. Who else is around? All right, so welcome back, folks. I'm going to take your questions during the second period. This first period, let's work through some titration ideas. So grunt, and find out, first off, where we were yesterday. I think we had HCl and NaOH. And there was 1 molar of both. And we just talked about trying to get the pH if we have if I have 49.99 milliliters of NaOH added. And we had, starting off here, we had 50 milliliters of this stuff, 50.00 milliliters. Okay, so right at the bell rang, if I remember, we said we got 50 minus 49 equals 0.01 milliliters of essentially H plus. So let me pause and just let you guys catch up and find your spot, and hopefully that's where we ended off. Folks here can move up if you want to, so you can see easier. That'd be fine. Okay, is that where we left off yesterday? Okay, so we have a strong acid and a strong base. So that's the sort of titration that we're talking about. But we're almost there. We have milliliters of H plus, but we really need to change that to moles and then divide by the number of liters. So we want to get this, the H plus concentration in moles per liter. Okay, that's kind of what you got to kind of aim for when you got milliliters. So you can either change this mentally, or you can go like this and say, okay, milli. This is how I might have taught you at the start of the year. Milli, if I get rid of milli, it's like multiplying by 0.001. So that gets rid of the mill part of the milliliters. So I end up just with liters. All right, how can I get it to moles now? What can I multiply by to get this sucker to moles? So essentially I've got rid of the milli, so I got liters. I want to get to moles. Hold on. No, I don't want grams. I want grams. Answer P. Moles over liters. Trying to get to, Lola, is we're getting moles per liter of the H plus. So we're just working on getting moles right now. So the liters goes, and answer P gave me the right labels. What's the number? Somebody else. So how many moles per liter is this thing? It is, Alicia? No. I don't think so. It's amino. It's just one, I think, isn't it? Yeah. So it's 1.00. Yeah, I should label this. It's H plus we got left over. So I'm going to get then moles of H plus. Now we can kind of do this mentally. One, of course, is easy. Check this out. I got 0.01 times 0.001. I bet we can do this. So it'd be 1 times 10 to the negative what? Can you do that? That'd be to the negative what times negative what? So you should go do that mentally. Negative, Anthony? No more, because that alone would be negative third. I got this times it also. Negative, thank you. There we go. So it's that many moles of H plus. We're almost there. We got to change it to moles per liter, and then we got it. Okay, so here we go. 1.0 times 10 negative fifth moles, not a lot, divided by, okay, what's our total volume now? What is it sitting in? Think about what you've added. What is it sitting in? Yeah, but how much? How much stuff? Like we got it by the amount of liters. Penelope? That's it. One more time. It was in 50, and we added this. You know what I'm saying? So altogether, it's sitting in, Ellie? Yeah. So it's almost 100. 99.99 milliliters. Well, let's just change that to liters, can we? That would be how much? 0.9. Thank you. So 0.9999 liters. Okay, so it's pretty close to just one. In fact, mathematically, to be honest, can you see how that it's just going to be 1 divided by, sorry, it's going to be 1 times 10 to the fifth, pretty much divided by 1. Wait a minute. Now there's something goofy here. Did I screw up? Hold on. Oh, I screwed up another year. No, I screwed up this year. So it'd be 99.99 milliliters. This is not right. It would be, thank you. Thank you. Okay, so now let's try it. Good. So that's essentially dividing by 0.1. So this would be, either somebody punch it out or do it mentally. You're dividing by 0.1, essentially. I think that's it. 1 times 10 negative. Oh, wait a minute. No, wait. Is it? It'd be, yeah, negative 5 now over negative 1 be negative 4. Negative 4. Remember our rule last time? If the front number is 1, what's the pH without having to do it in the calculator? So if it's 1 times 10 negative 4, pH is going to be, what number to do it mentally? 2 people got it? Another? 4. So if the front number is 1, then you just take the opposite of the power. That's what log is, really. If it's not 1, you've got to do the negative log of that, right? But here it's nice. It's nice. Anthony. What? Ah, okay, good. Let's talk about that. I kind of erased it. I think we had it last time, Anthony, but let's put it on the side to remind ourselves. Essentially, we got this. I got 50.00 milliliters of H plus, right? That's from acid, plus some whatever amount of OH minus. And the deal, as long as it's 50 or below, Anthony, those suckers are going to get together and make what chemical? So to be honest, the only thing I have, if I got 49.99 milliliters of this, and they're both the same concentration, really most of it has become water. So I got water, and then plus, still I got 0.01 milliliters of H plus left. That's all I'm trying to say, Anthony. The rest has become water. And once it's water, we don't really care about it. Okay? We need to know how much, but we don't really care, like, how much is there. All right, and we don't care if that is water. Ute. Okay. Okay. What if I have, this is kind of obvious, I think, because this is like ninth grade. If I got a strong and a strong, and the pH, if 50.0 milliliters of NaOH is added, 1 is added to 50 milliliters of 1 over HCl. So what if I got 50 and exactly 50? And what's the pH going to be? About Alex? I got 50, and then I had 50 of the opposite, 50 of the acid, 50 of the base, and they're both 1 molar.
I'm not quite.
Chelsea? 0? No, 0 would be highly acidic. I think you want another number. 7. So that should be from 7th grade. Okay, if you were here, you had acids and bases, and we said if they are equal amounts, then it's neutral. It's a pH of 7. Turns out that's true if it's a strong and a strong, and you got the same amounts of molar. A little sloppy there. They're the same concentration, and you're good. Thank you. Exactly. Can I move the camera to the side a bit? This side? You tell me if that's better. Okay. Now this is kind of weird. Okay, check this out. When I had 49.99, my pH was 4. That's enthalpy, fairly acidic. And yet I added 0.01 milliliters more, and suddenly it's up to neutral. You remember that graph we did yesterday? Which was pH and milliliters of NaOH added. Why is it this way? There's 7. What do you notice about the curve? Why does that make sense, what we got here? Why does that make sense based on the graph we kind of drew yesterday, Lola?
Well, yesterday we determined there's very rapid change when it's going from acidic to a neutral. So
Thank you.
at 7, and it was at 4 before it makes sense that it goes so rapid.
Super, and well described, a rapid change. So we went from like here to here to here within like not even a milliliter. Every milliliter has roughly 20 drops in it. Check this out. This would be like 1 drop more, right? 1 drop more, and suddenly I go up 3 pH numbers. That's a big deal. Would that happen if I had a buffer in there instead? No, not at all. It wouldn't do anything, right? Yeah. So this really matters here. Okay, last thing. Let's find the pH if we add 50.01 milliliters of OH minus to the same thing, okay, to the 50 milliliters of well, this time we're going to have how much left over of what chemical? What will be left over this time? And how much? And Sophie? Exactly. So, like I was talking to Antonin about earlier, once the OH minus and the H pluses pair off and make a bunch of waters, we don't care about them. So all that's left over is exactly that. And isn't that the same number as up here? Isn't it going to be the same math? You know what I mean? So let's get the OH minus concentration. Remember, we want the pH, but for this one, I'll have to first get the P. No? POH. POH. The pK is going to be really big for HCl. It's just an infinitely big number. Now I got to get the POH because I've got that left over. So I want moles per liter, and it's the same amount of moles as up above, right? It's 0.01 milliliters changed to moles. So let's just do that. 1.0 times 10 to the negative fifth moles OH minus. And in your notes, you can say like up above, you know what I mean? It's the same calculation. Same calc as above. Good. By how much liquid is it sitting in? We're going to talk. I haven't talked to Feeney yet. Feeney, how much liquid is it now sitting in? Just do it in milliliters first.
In total?
Yeah.
I was doing it today,
All right. We still got the 50 milliliters of acid, and now we're adding this much base.
100.01.
Yeah. Now we're going to change that to liters mentally.
1
Keep that significant figure. I know when I do that calculator, Feeney, it's not really going to matter much. Yeah. You got it. Let's do it, everybody. We can do it mentally. So we're dividing 10 to the fifth by 10 to the, 10 to the negative fifth by 10 to the negative 1, right? So that'll be what power? Negative 4. Thank you, Aiden. So it's 1.0 times 10 to the negative 4th molar. Now, if you don't believe me, you can punch this in, but this one way over here really doesn't do much. It's not really significant. And so, Pete?
I punched it in and I punched it in and I got punched it in.
Yeah, but then you got to divide it again by 0.1. You still got to do that.
I did.
No, it should be negative fifth, and then we got to divide it by that.
I did, and I got 10 to the negative fifth.
Did I screw up somewhere?
I got 9.9 times 10 to the negative fifth.
Well, yeah,
It gets to 0.001.
right.
It's the same.
But I think if you round that, isn't it 9.99 or something like that? Round it. So then we 1.0 times 10 negative. It's the same number. If you round it, Anne-Sophie, it should be the same number. In other words, the number she got, 9.999 whatever times 10 negative fifth will be the same as this times 10 negative fourth. Okay. Yeah, you're right. So sorry about the confusion. Okay, everybody. Mentally then, if that's the OH minus concentration, what's the pH number? Over to Louisa. The pH number. 4. And if the pH is 4, Louisa, the pH has got to be then what other number? What do they add up to? Well, they add up to 14. So what'll be the pH?
Sorry.
That's 4. They add up to 14.
Oh my God, this is very 10.
10. There you go. Is that Penelope acidic or basic now? If it's got a pH of 10. Basic. And pretty basic, isn't it? Like 7 is neutral. So again, I added just a tiny bit OH minus, and that really changed the pH a lot. And it, Lola said earlier, is really steep graph here. It's really steep in the middle where it's rapidly changing. questions, comments from you? Anthony and then Penelope. No. We got the pH for both. But to get the pH for this one, I had to get the POH first. I know we don't often use POH, Anthony, but it's just a way to help us get the pH. So I wouldn't worry too much about the POH except for, okay, that was 4, fine, but then I know it's 14 minus 4 to get the actual pH there. Penelope.
What was the difference that we did before with the pH 4?
Okay, the difference there is, and the only difference, Penelope, and everybody is this. Left over here, Penelope, we had 0.01 milliliters of H plus. Left over here, we had 0.01 milliliters of OH minus. That's really the only difference. The rest of it, the math is identical. But because I had a different chemical left over, now suddenly it changes everything in terms of the pH. That's okay.
At the same time, we would be for the pH of the POH
You need 2 times 12. Absolutely. Okay. Especially if it's some sort of multiple choice question, do these quick. That's why sometimes I say, hey, let's do these mentally. I'm trying to get you charged up for multiple choice questions, okay? Okay. I know it's exciting. Mental math. Woo, woo. Come on, that's everything about a strong. So essentially, unless it's right at 7, you got to subtract and see what's left over, and then get the concentration of either the H plus or OH minus, depending, and then divide by the total volume. That's it. So let's look at a weak strong. See if there's any questions here. Basic is right. Yeah, 10. Basic. Thank you, Bella. Basic for Bella and B. Okay, so. Okay. There we go, weak acid, strong base titration. So we're going to use a really similar example to the last one, but we're going to change the chemical. So instead of HCl, what's a weak acid we talked about, I think, last time? We even made a buffer with it. What was a weak acid we made the buffer with? Was Penelope? HI, no, HI is another strong acid. Now this one is, we made the buffer with it last time. Arrow?
HCH.
You got it. Acetic acid. That's the name of it, and it's the stuff in vinegar. And that is it exactly. So we got 50 milliliters of 1.00 molar acetic HCH3COO. Oh, damn mask. And for this one, you get something you didn't get last time. Last time, I think Aiden said the word Ka. The Ka for HCl is like infinitely large, so there's no number for it. This one's weak acid, so you get the Ka. We'll need it. It's 1.8 times 10 to the negative 6, I think. No, negative 5. Okay, acid is titrated. It's still on my screen for them. Kind of. It's titrated with 1.00 molar NaOH. So we're going to keep the same strong base, okay? Good. Find the pH. It sounds sort of silly, but find the pH first if 0 milliliters of NaOH are added. Well, then we're going to do it like a Ka problem. A Ka problem. Let's take our chemical. And we're going to write a reaction. Remember, anytime you got a weak acid or a weak base, start with the chemicals and have it breaking up. Alicia, that's going to break up into what? Thank you. If it's in Cheryl's book, again, it won't be H+, it'll be H3O+, and she'll be adding a water part, but I don't like doing it that way. To me, this looks cleaner. But if I see H+, you can always think on the AP H3O+. Okay. Huge. So I've got pure acetic acid. I don't need to worry about this at all. So let's go ahead and write the Ka. What would the expression be? I knew that was going to happen. Ay, caramba. Come back here. I want to grade those labs. Really. Come back. Whose was that? Antonine, I almost lost your lab. But I see. Okay, so. Ole peole, inspector. Good. Who do I ask? I can't remember. Amina, what's the Ka expression? No, the Ka is over here. Okay, so a little while since we've done them, but a weak acid problem is they're all the same. You do the acid breaking up, you do the Ka expression. Now you start thinking, okay, I want pH. That means I'll have to get what out of this expression to help me get the pH? What would do it out of there? What would do it out of there? Anthony? I don't see any OH. No, there's no OH in there. And Sophie? pH plus. If I can get that, then I can get the pH from that. Now, I don't know what that is. I'm going to call that X. What about the CH3COO minus? Penelope, that's going to be, if this is X, I can say this is for every one of these, I get one of those. And so if this guy's X, then this guy. Exactly. Good. The bottom, the concentration of the whole chemical is what? Just so you're all following. 2 people see it. 3. Concentration of the whole chemical. Alex is what?
1.0.
Thank you. Okay, so let's put all that stuff in. 1.00 X squared. And the Ka, they gave it to us. Hallelujah. 1.8 times 10 negative fifth. Can you guys pull out a calculator, please, and find X? Let's agree what it is and what it is we found. Jesse, what'd you get?
I got 0.0042. So can we just say 4.24
Times 10 negative.
times the negative 3?
Negative 3. Let's see if others got the same thing. More or less? Okay, good. And that's going to be what now? That's molar. And we found what important thing? Because I want to label it as such, Alex. Good. Now, could everybody take the negative log of that sucker and let me know what the pH is? I won't write negative log because I think now you know how to do that successfully. Okay. How about Arrow, you got it? You don't have it. Penelope, what'd you get? Well, it would if this was a 1. If it was a 1, it would be 3. She's right. But it's not going to be. So this one, it's not going to be exactly 3. So this one, Penelope, actually, you have to take the negative log of. We can't really guess it. Ellie? 2.4 rounded. Others get the same. Thank you both. Good. Yeah. So it's not 3 because the front number is greater than 1. So 2.4. So it's a weak base, not super weak, but a weak base. And we're ready to actually start titrating.
Wait, this is 2.4 the POH.
No? Remember you said it was the H plus in here.
You just make the negative log on the POH.
Yeah, the negative log. No. To get the POH, well, you just take 14 minus this number.
Oh, so it's negative log on the pH.
Yeah, negative log of the H plus to get the pH. Okay. Exactly. So if it's a weak acid, it better be something acidic anyway. So it better be below 7, and it is. Okay, let's add some base. Okay, let's add this time 25 milliliters of NaOH. Now, my people, I'm not choosing this at random. Why 25? What was our original amount of the acid? In other words, it's not luck. Lola? 50. So it's exactly half of 50. That is not luck. And you're going to see really quickly why I chose that and why books and the AP often choose that. The other one, we choose like 49.99 just because it's an interesting number to show students this. But this one, it's 25, exactly half of the starting amount. Why is that? Okay, let's. Well, if I got 50 liters of the acid plus 25.0 milliliters of base, what happens, folks? What's left, so to speak? What's left, Amina? Yeah. And that acid, let's write it, is HCH3COO. Now, here's the difference. I want to write in a little equation what you've just done. Okay, HCH3COO plus a bunch of OH minus. Because remember, it's a strong base, so I'm getting OH minus completely from the base. Okay, what's going to be formed? Alicia, what's going to form now as products? This whole thing plus the OH minus. Remember last time with that strong, I said we don't care about the water? We still don't care about the water. But now we got something else. This we care about. Essentially, didn't 25 of this react with 25 of that to make 25 of this? Now look what we got above. Or 25.0 if you like. I got 25 milliliters of this stuff, and I got 25 milliliters of this stuff. What do I have, people? Yeah! And not only is it a buffer, it's a 1-to-1 buffer. Ah, that's why the AP often have 25 out of 50 or 50 out of 100. You know what I'm saying? So look for those on multiple choice questions, those ratios. So it's a 1-to-1 buffer. Yeah! Just like Lola, I want the rest of you to be able to sniff that out every time there's a buffer. And you'll have that on a number of problems with me and with Cheryl as well. Yeah, good sniffing. Okay, so you smell the buffer. Let's figure out what that means. Oh, it means I can use the handy dandy buffer equation. How about we go right to the pH one? Can somebody find that one in their notes? What's the pH one that's so handy? pH equals, Louisa?
pKa plus log, and then base, B minus over H.
Thank you, super. Good. Okay, let's plug it all in. You ready? So pH equals the negative log. I don't know the number, but we can just do it in the problem, right? The negative log of the Ka we played with over here somewhere. That guy. So it's just negative log, right? pH negative log, pKa is negative log of times 10 to the negative fifth. That was our Ka, so I'm not pulling that out of my hat. We still have the same acid as part A, the acetic acid. There's the Ka value, plus the log. Now let's think a little bit. I could do a lot of work here, but I don't want to. I'm an AP student and I want to do this problem fast. Why would you argue you don't have to figure out the concentration of B minus and the concentration of HB here? Alex, it's a 1-to-1 ratio. Let's prove that to each other. Okay? It was 1 molar NaOH. It was 1 molar acetic acid. And I've converted from the 1 molar acid, I got 25 milliliters of it left. From the base, I've converted 25 milliliters from the acid. So I've got the same amount there. Can I say that?
Will be 25 milliliters of the acid left over and then 25 milliliters of converted base in the solution of water.
Maybe that's the easiest way to think of it. To be honest, I now double the amount of liquid, don't I? So maybe they're both 0.5 and 0.5, but does it matter? Doesn't, right? So let's just do it the way Lola suggested. I got 25 milliliters of both. I know this is not milliliters, but if you're starting with the same concentrations, then you got equal amounts of both the weak acid base. So the H3CO3O minus and the CH3CO minus. No minus in the first one. Anyway. So that's log of 1. Alex. Beautiful. So it turns out the pH is just the negative log of that. Can somebody crunch that out? You got it already, Amina? That's just from the equation. That's like the formula. You can put A minus and HA if you like that better. It's just the conjugate base on top and the conjugate acid on the bottom. Chelsea.
I got 4.74.
That check? 4.74. So 4.7. 4.7. Aiden,
So kind of confused how it's the 1-to-1 ratio. You have like 20 milliliters of leftover acid.
no, 25.
25 milliliters of leftover acid, and then 50 milliliters of I thought was buffers.
25 milliliters of your water.
It's kind of like what we did yesterday. I took a bunch of the acid solution and I added like half the amount of base to convert some of it over. So we did that here. Check this out. If I did 50 and 25, then essentially that 25 of that base is gone, or the OH minus. So that's gone. And I got 25 milliliters left of the acid. All right? But turns out this OH minus stuff, it's not gone in this equation. It becomes this. And that's why it's the same amount. So like half of it, Aiden, is converted over from this stuff to the conjugate base. So I got half of each of these, which made it just a nice 1-to-1 ratio. Other questions from you before we continue? Good. Part C, and then we're done with this one too. So part C says, what if we pH if 50 milliliters and your OH added?
On top of the 25.
No, total. Total. So what that means is, let's look at our equation again. Here's what I was talking about with Aiden. So look at us, I got 50 of this, and 50 of the OH minus. That means, essentially, I've made completely what? What's interesting on the other side? Enthalpy? Not neutral. What have I made? What's, other than the water, what have I made that's important? What have I made that's important? Let's write the reaction again. This part's really essential. Each of you get it. So I got the acid. I got the base. But a base here, it's the strongest, the NaOH. So I'm just going to add OH minus, okay? Because the Na plus is a spectator. You know that. Forms water. Because this H goes with that OH minus and makes water. Plus what? So what's the important thing that's left, Amina? Good. And frankly, folks, that's what I've got. I've got completely that stuff. Ah. Hmm?
Why completely?
Louder.
Why do you have completely pH?
50 plus 50, totally gone. So every one of the H pluses here has been grabbed and pulled off enthalpy by an OH minus. And again, folks, it's not disappeared. I just have lots and lots of this stuff now floating in the water. So we're not done, but that's the biggest part of this problem. Once you realize you got this, the rest is a lot easier. Oh,
So the reaction went to completion, it's just left over with the basic solution.
yes, we have a base solution, and now we're going to figure out what to do with that mathematically in just a second. Anthony?
But from this, though, we can't tell how much.
Oh, yeah, we can. And it's not left over. Let's call it how much we've made. Okay? We made essentially, folks, how many milliliters of it did we make? $50. But, hold on. I know where you're going. Don't get all panicky. But it's sitting at how much total solution now? It's sitting at 100. Okay, so I just wasn't there yet. Okay, don't go away. Stop just a sec. I double the amount of solution it's sitting in, then instead of being 1 molar, what's going to be the concentration of the stuff? Aiden? No, not 2.
0.5.
0.5 molar. So 0.5 molar CH3 COO minus. We'll see what to do with that right after break to get the pH, and then we really will take your questions. Woo, take a break.
I was having a conversation with Mr. Wilborn and the county went longer than expected.
Thanks, Alex. All right. Any other labs, folks? Acid-based labs that you want to turn in? You can't see any of B. Well, that's terrible. I'm so sorry. There's B. There's B. Good. There's that.
I know I did them, I just don't know if I necessarily answer all the questions I did.
Well, check it out and see. Yeah, good. Thank you. Good. Are others out there? Bella's the only one. I don't know, my Oscar or do I?
And for 5, would be more because it has 2 NAs. You think we over this? Okay. We did it together. I just have to. Okay, thank you, because I'm.
Wait, right? You have a point, right?
Yep. Junior calc class or?
I was about to ask that to like argument.
No, I took that class last year. You think you'll take the next class next year? The class
Probably, yeah.
Let's put it in.
Pretty good at it.
Yeah, did everything.
Not looking at the book. I'm just putting myself underneath this book. Not like looking.
There we go. Yeah. It's the first year that they're gonna be in the yearbook. I think I've been here for 12 years and I'm just now, it's like the summer of the main month. It's just. Just on it, oh. And we just watched people, but the book was like really excited to have it took the big. That's, and it's like, oh yeah, he's gonna be some food and you can see pictures of me doing it. It was really fun. Yeah, and then we just picked up the platform. Yes, that one. It was so cute though. It was so cute. It was really random. I was so cute. I was like, I saw it. And yeah, and then afterwards she told her, yeah, this is what you did before. And then she's like doing it, and then she turns around and goes, I can't take when someone takes pictures. Okay, just have to do you don't mind if you do that? I don't mind. It would be the mask is on. I think who were wearing their hat. Very something, but not like that. And then afterwards, is a trial. So many questions about like, Oh, I think. Okay.
Can I just to the bathroom quickly? If I don't make it back, and
Yeah. Sure, set that down, I'll be ready.
alright.
Okay, which one you on?
Okay, I will just
All right, let me read it. Calculate the pH of 0.3 molar SrOH2. So we're going to assume it's going to be 0.6 molar OH minus.
okay, because I tried doing the exercise.
No. This is a strong base.
Okay,
So all you do is say, okay, I got 0.6 molar OH minus.
okay.
Because it's one of the 6 strong bases.
Okay.
Okay. Yeah.
I need a lot of all of it.
I have a question. So you could sit in the back. So yeah.
Okay, so right before break, we realized that we had nothing left of our weak acid. It's all been converted to weak base. So what that means is we've got a problem we haven't done in a couple of weeks. It's called a KB problem. So all we have is the CH3CO minus. That's a KB problem. We agreed that it's 0.5 molar now because it's sitting in how much liquid? Why do we get that it's 0.5 molar, Ellie? Thank you, exactly. 100 is, so if we double the liquid, it's half diluted, right? Half of the concentration, which makes sense, right? If I double it, it should be half the concentration. Anthony?
So we're just making the assumption that water.
It's not an assumption, that's just the reaction. That's what's happening.
That would always happen, but it's perfect.
So if I got like a 1-to-1 relationship, then I got one of those, and water I don't care about, and I got one of those. So if I got instead 50 and 50 milliliters, then I got, well, that's probably a crappy way to say it. If I got some number of moles, same number of moles, then I'm going to get the same number of moles of this, but now it's in twice as much liquid. So instead of 1 molar, it's now 0.5 molar of the base. Okay, let's do a KB problem. The first way to do it is write a reaction so you know what's happening. So what do I got? I got CH3COO minus. And it's sitting in what? What's the only other thing it could react with, which is kind of weird? It's sitting in what? It's sitting in the water. So ironically, this is going to look really strange to you. It's essentially going to go backwards. So just like we did with some of the anions when we talked about salts the other day, it's going to split up the water. What part of the water is this guy going to grab onto? Arrow, what's it going to take off the water? H plus. So I got H, CH3COO, and then what's left if I take off the H plus? Right. And that's why it's going to act like a base, because I'm making some OH minus when we do what Errol just described. Do the expression. I'm going to just do this for you, because I want to take your questions once we finish the sucker up. Okay, let me pause till all of you get that far. So it's a KB expression. We wrote the reaction for what's happening. I wrote an expression. Eventually, we want to get the pH out of that KB. What can eventually lead us to the pH out of this expression? Eventually, we get the pH from what? From Alex? The OH minus. So eventually, we can get there. Okay? All right, so let's see what's going on. Well, you know the game, right? For every one of these we have, I make one of these and one of these. For every X of these I got, I'm going to make, and Sophie? Now 1. Let's change it now. For every X of these I got, you got to put in a variable. That's why I'm asking you that. Exactly. So on top, and Sophie, I'm going to get what then? You got it. And on the bottom, it's the concentration of, Chelsea? Yeah, so we decided it's now not 1 molar, but 0.5 probably molar, if I think about sig phase. And now the KB, we don't have that, or do we? We had a little, I'm going to do a little side thing. Remember this, the KW is equal to the KA times the KB. That sucker, that little tiny phrase is worth its weight in gold. What was the KW number? Who remembers? Remember W's for water. What's the magic number? You have to memorize it. You remember it, Penelope?
1.0 times 10 to the power of
Exactly, good. What good is that? Oh, the good is we got the Ka in the previous problem, right? It's the same stuff. The Ka for this thing, the acid, was 1.8 times 10 to the negative fifth. And folks, that's times the Kb. So could you maybe find the Kb here for me? Can you punch it out so I know we can agree on the answer? And then we just about got this guy linked. What's the Kb? If I'm able to do that. Amina, what'd you get? 5.5 times 10 negative 20th? That seems odd, because I think it's divided.
I got it to the negative 10.
I think negative 10 sounds more reasonable. What'd you get? Ellie, what'd you get?
5.6. Um,
Check that again, Amina, because I think if I divide negative 14 by negative 5, like the powers cancel out a little bit. Negative 10 sounds better. Well, it's negative 14 divided by negative 5. Put stuff in parentheses. Something's goofy. Something's goofy. I got to put it in parentheses and divide. So, like Aiden, you got to have this guy in parentheses divided by this guy in parentheses. And it should be times 10 negative 10. So I'm going to put that in over here. Okay, let's crunch it out. One last calculation. So, multiply the 0.5 over, take the square root, and we know what you get. And then let's see if we get the same thing this time. And then we're going to see what that is and why we're just about done. What do we get? Lola, what'd you get this time?
I got 1.7 times 10 to the negative 5.
Good. Let's see if that matches others. Yep, thank you very much for doing that. Good. So what is it I found? It's now a concentration.
Teachers, pardon the interruption. This is a quick announcement for 11A students that you should, before you leave today, either after 7th period or 8th, come by W116 and see Frau Aust for a package of Schnell tests. Again, only for 11A. Please come and pick up your Schnell test back from Frau Aust or Frau Kruger. Thank you.
Okay. So what is that? What is the important thing we found here? Why are we on our way? Amina? OH minus. Beautiful. Let's get the POH, can we? And it is, Anne-Sophie? 4.8 rounded? Or 4.7? 4.8? Okay. So then, mentally everybody, so what's the pH then? 9 point? You got it.
How do you get the POH?
POH, it's the negative log
Okay.
of this thing.
Okay.
Negative log of that. Okay. Good.
Wait, so that means we can take the negative log of the concentration to find both pH and POH?
That's right. So if I take the negative log of the OH minus, I get the POH. And if I take the negative log of H plus, it's a pH. Anthony?
Isn't it when we start with 1 that we can just take the power?
Yeah, but it's got to be 1.0. 1.0. It's the only time you can do that. But it's good you're putting that to memory because I will pay off, Anthony, when you see some quizzes with that. Okay, so look at this, folks. This is the pH right at the equivalence point. That's when I had the same amount of acid and base. You can tell it's not at 7. It's very, very what? Very basic. Not weird. So what indicator would you choose? When you go back to yesterday, we had a list of 3 indicators. Which one changes when it's more basic? We made a little table of 3 indicators. Which one changes if it's more basic? Penelope? Phenolphthalein, you got it. So use phenolphthalein. What about the first one we did where it changed right at 7? What indicator would you use for that one? Ellie? Bronchithial blue? Bronchithial blue. Yes. But here's the weird thing. For that first one we did, you can use any of them. Why? It has to do with something Lola said about our graph. Why can I use any of them? And I'm going to show you a graph of this one in just a second. Why can I use any of them? Yeah. That first graph, remember how it looked? Watch how this graph looks. And 7's like here. And what was our equivalence point? That was at 9.2. You know what I mean? So it doesn't have the same shape. It's more squished out instead of the other one that went really steep. The one we talked about with these two. That really makes it so you can use any indicator. Here, our equivalence point is right there, gang, at 9.2. And I can really only use phenolphthalein to accomplish that correctly. When I see you Monday, we will do the 3rd type of titration, which is a strong acid weak base. For now, I'm going to stop yapping and see if you have some questions on chapter whatever. I know we're fairly spread out. I understand that. And I'm guessing you'll be trying to catch up as quick as you can. Oh, there's that other graph, by the way. So do you see the other graph, whether it's at 9 or 5, it doesn't really matter. It's all happening within about a drop. So it doesn't really matter for that other graph. I'm going to go right across. Alex is leaving. Okay, Anthony.
I have a question for the opposite where you're solving for strong base acid. Wouldn't it just be the opposite? You're solving for Ka first and then
Pretty much. It's going to be really, really similar to what you said. Yep, really similar. Good. Other questions on book problems then we'd like to see. Alicia. 292? 292, 2. Okay, everybody turn to 292, 2, and I will too. Sorry. So 292 is acid-base stuff. So let's have a look at number 2. Even if you haven't gotten that far, go ahead and write some of it down so you have an idea how to start. It says calculate the mass of NaOH that must be added to 500 milliliters of 0.2 molar HI. HI was a acid. HI was a acid, Penelope? Strong acid, good. In order to get, in a solution with H3O plus concentration of 0.12 molar. Assume no volume change when we add the NaOH. Okay, good. That's nice of them. Okay, here we go. Do I have a certain amount of this? Let's see. Oh, 500 milliliters, sorry. Thank goodness. Okay. What sort of, it's not a titration, but what sort of reaction is this? Strong, 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 weak, weak, strong. What is this just by looking at the two chemicals? Good, several hands already. It would be, Aiden? Yes, with strong, 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 weak, weak, strong.
With strong.
Strong, strong. Okay. What that means is life is good because I don't have to do Ka or Kb. Instead, I can just kind of go like this. For every, you know that this is the same as what other ion? What we were saying, Anthony? Okay, so I want to neutralize the H plus with OH minus, and it's 1-to-1, isn't it? One of those will take one OH minus. That means your life is really good. Let's make a plan. I don't often make plans, but I think this time it'll be useful. I'm starting with milliliters of HI. And eventually I want to get grams NaOH. Lead me over there, just like we did at the start of the year. I'm probably going to change milliliters of HI to moles. How about first to liters of HI? Well, we can do that mentally. To moles, HI. Then I can probably change that to, and Sophie? Super. And 2 grams of NaOH. Voila, you're done. So this is just a big hunkin' bunch of conversions, and then that is really it. And again, the way I know that after today is, oh, it's a strong with a strong. So that's how I can do that sort of problem. I think, Alicia, unless you have a question about it more involved, can I leave you with that to try it? Okay, all right. So everybody else, I think that's a good plan. If you write that down, when you get there, you'll think of how to do it if you're not already there. Good. Other ones we'd like to ask about. Any chapter you're working on? Any from Bella or anybody else out there too? Ma'am? Page 299, okay. Now which one? Okay. Let's have a look at it. So acid basis again. Number 3 says, a student calculates the pH of a sample of concentrated nitric acid to be negative 1.20. Should she put her finger in there? No. Ouch. So pH is negative 1.20, and it's nitric acid, HNO3. Yow. She thinks she has made a mistake because the value is negative. Calculate the hydronium concentration of this acid and decide if it was an error. Why do you think expressing pH for concentrated strong acid solutions are not really necessary? Okay, well, let's go ahead and do it. So if that's the pH, help me get the H plus. Who remembers? What do I got to do with this number? Don't worry that it's negative, but what do I got to do with it? What's the opposite of pH, Chelsea? Yeah, 10 to the, yeah, it's the opposite of the power, so she's right. It'll be 10 to the 1.20 power. You know what I mean? Okay, good. Do that. Do that. What would that be? 0.8?
Oh, yeah.
8.5. That's a lot. Let's round it. 15, 16? What label do we end up with? Kind of a weird label. Penelope? The moles per liter, right. Whoa, that's super strong, isn't it? So is it a mistake? Probably not, but it would be a really nasty strong solution of HNO3. 16 moles of it per liter. Ouch. So,
My question was more the last part.
the last, why do you think expressing pH values for concentrated strong acids are not really necessary? Here's why. The Ka for strong acids is what sort of number? You got it. It's huge. What that means, to be really honest about it, is anytime the strong acid is like 1 molar or bigger, it's really acidic. And in terms of a person using the acid, anything 1 molar stronger, you just have to be really careful. You just don't want to get it on you. I think that's what they're after, something like that. Okay, that's chapter 5. Anything in chapter 4 or 3 that someone else is working on, this is a good chance to get you some guidance here, okay? What else are you working on? There should be marking problems in your book that you want to ask about. Any from here? Yes, I got one from Bella. Okay, so let's take this page 247. And it's 1, whoa, I lost part of my screen. 1D. Okay, here we go. So everybody turn to 247. Let's have a look at it. And we want to calculate the solubility. So we're back with KSP. The solubility of strontium fluoride. In grams per liter. Good. Somebody give me the formula, strontium fluoride. How about the charges on things? Louisa, strontium is like what ion? Okay, fluoride is what ion? Fr? No, it's not. That's francium. So Penelope, how about it? F minus. What about strontium? Okay, good. Somebody else. Errol, give me the formula for this thing. Good. That's why I ask you to memorize the ions. You have to do it. You have to do it. Okay, so we want the solubility. I got to look up the KSP, which is back on the previous page. So there it is. Strontium fluoride, KSP is 4.3 times 10 negative 9. And let's do the D. Here we go. So solubility means how much does the solid dissolve? I got SR2 plus. I got that from Penelope already, and I got F minus, and to balance it, 2 of those, right? Slow down here, and give me the expression. The expression. Chelsea?
I think the composition of FR and the composition of F minus squared.
Good. Somebody else. Why did Chelsea leave out the reactant? What's wrong with the poor reactant? Alex? Thank you. So we leave those out. Now, let's have a look. We got the KSP. That's 4.3 times 10 negative 9. It's not a mystery. You'll be given it in the problem. I got it from page 245. Okay. And, okay. This is the amount soluble. And remember this game, S and 2S? Remember that kind of weird thing? We did that a couple times. So what's going to happen here, Penelope?
It would be 4x.
Good job. So it's one of those that ends up being like this. 4s squared times another s. She's right, it's 4s cubed. Now, I could get this thing, but it's going to be in moles per liter. Whatever you guys get, moles per liter. And Bella, I'm going to ask this, if this is what you did. The problem asks for grams per liter. So once you get this answer, I still got to multiply by what? 1 mole and grams. I got to multiply still by the molar mass. You did convert to grams. Okay, let's see. Can somebody get this? Let's see if we got the same thing as Bella got for this. Okay, somebody get me the S here. So divide by 4 and get the cube root. We're going to check with you, Bella, and see. What'd you get? Penelope, what'd you get?
I got 1.6
-3?
Yeah.
Okay, let's see. Is that check with others? Thank you very much. Yeah, okay, good. Okay, Bella, did you get the same thing? What did you get for your concentration, Bella? Did you get this? 1.6 times 10 negative third for your S. 1.0. Well, that's why lots of people do it. Well, I got 2 different answers. Maybe everybody punch it out again. But it's times 10 to the negative third, right? Okay, so 1.0 or 1.3. Everybody divided by 4 and then took the cube root. 1.0. All right, I'll go with that. Let's see if she got that. Okay, all right, so she's all set now. Okay, so, and then you're going to multiply by the molar mass, everybody, then you're there, right? I'll let everybody finish it up on their own. Good. Other ones we'd like to ask about in any of the chapters? By the way, let's talk about next week a little bit. Monday will be here, relatively normal. I still have to decide if we can do a lab or not, but time-wise, I just don't know if I can get one in or not. Wednesday will be online, and I'll pick a time, and I'll send it to you probably, that's our Wednesday day, probably like 10 to 11:15, if that'll work for you guys. And then the Thursday, Ellie, remind me what we're going to do Thursday? Okay. So, yeah, so that's kind of what we're doing next week because you've got something before that, and then it'll give you some time to get home, okay? If you're a little late, just join us, okay? And that's how we'll do that, okay? Good. Any others? How are we doing on time? We still got some time. I'm going to start, if you don't have anything else, with the third type of titration. All right, then let's do it. Okay, so head back to wherever you're keeping notes. And we're going to do the third type of titration. Whoa. So which is a weak strong. No, which is a strong weak. Hallelujah. Then we're cooking pretty well, people. Okay, so strong acid weak base. Just think about what you wrote. Strong acid, weak base. Probably once we hit the equivalence point, where it's the same amount of acid and base, who's going to win? Will it be more on the acid side or the base side? What's your guess, even before we do it, Aiden? The acid side. So it'll be probably closer to what sort of pH numbers? Anthony? Yeah, well, maybe not that negative, but certainly below 7, right? Okay, look back on your chart. Which indicator probably is going to be the best of the three to use from our little chart of indicators last time, Anne-Sophie? Methyl red. So equivalence point will be on the acid side of 7. We'll use methyl red. Dynamite. I'm glad you guys understand that. That's really good. Let's do an example. At least we'll get some parts of it done. Okay, I got 50.0 milliliters of 1.0 molar NH3 is titrated with 1.0 molar HCl. A, pH if 0 milliliters of HCl is added. Okay. Now, I haven't added any acid, therefore it's going to be what sort of problem? And Sophie? KB problem. Good job. So it's going to be a weak base or KB problem. Well, look at I got NH3. How do I know it's a weak base? Because it's not a strong base, right? And we got to memorize those, right? NaOH, KOH, SrOH2, BaOH2, CaOH2. It's not one of the strong ones, so it's a weak one. So, and Sophie is right. It's going to be a weak base or KB problem. So start doing a reaction to help you. We're going to throw the NH3 in water. We did this a couple weeks ago. The only thing that can happen is what? I know they're both neutral, but something's going to form that you're familiar with. What will form on the other side when this stuff gets and touches the water? Lola. Yine, not quite. Not quite, but something else you're familiar with, an ion you know. Aiden?
NH4.
NH4 with what charge?
NH4.
No?
Plus.
Yeah, and it's got an error. If you think about it, Aiden, it's got to be, because if it's NH3 and I add another H plus to it, then I got to have a plus on the charge. Plus, that's ammonium. You guys probably, I hope, still memorize that anyway. All right. Okay, good. What's left from the amino from the water? OH minus. That's why it's a KB problem, because I made some OH minus. Okay, let's do it. So the KB expression is products over reactants, NH4 plus times OH minus, and we leave the water out because it's a liquid. So I got NH3 on the bottom, and the K, oh man. Let's see if I just want to give you the KB. No, they didn't give it to me. Okay, so the Ka of this stuff is 5.6 times 10 to the negative 10. So I want you to, can we do it in the problem? Can we do it in the problem? So we said KB is the KA, but with the KW, how will I do that? So to speak, Chelsea?
You could just do the KW divided by
Good. So 1.0 times 10 to the negative
um,
14 divided by the KA, which we just got in the problem. I could do that separately if it bothers you, but that's another name for the KB. It's just the KW Chelsea gave me divided by the KA. Okay. And now let's put in some stuff. I got, oh boy, what do I got? Well, what's one thing I could put in and where? Alex?
You know, the NH3.
Thank you. Go. What about the top? What about the top? Penelope, probably going to be what and what? If we don't know? X squared. There's a lot of problems like that, aren't there? There really are. Good. Let's do that. So multiply the 1 over, divide these suckers, and everybody find out what X is. And let's see if we get the same number.
Divided by KB.
Yeah, the KB is that divided by that would be like negative third or fourth, something like that. There you go. Okay, so, okay, what do we get for X? What do you get for X? Amina, what'd you get? Okay, that check with others? It does, thanks everybody. So molar, and importantly, it's what thing in our expression that can help us eventually get to the pH. Lola? Good, OH minus, right? Good, can we get the POH? Take the negative log of that sucker, please. Probably gonna be what? 2 point something maybe? Because it's a little bigger than 1 times 10 negative third. And so what would it be to Anthony?
I have a question.
Yeah,
You would have given either the K or the solve the problem.
yes. Yeah, otherwise it really would not be possible. Chelsea? 2.4, is that check with others? Thanks for doing that. Okay, if the pH is POH is 2.4, what's the pH? Can we do it mentally? I bet we can. Hooray, they cried. Ellie, what'd you get? Super. So it is indeed a base. It's a KB problem. That is over 7, and it is a basic pH, so to speak. Yes. Sorry, Bella. I'll let you look at that for a second, and I will. Okay, and I will erase over here and continue over here. I'll move you over here in a second. Okay, good. All right, here we go. So part B, we're actually going to do something now. The pH, if we add, you can just about write this problem. How much are they going to add of something? 25 milliliters, exactly. The cool thing is, if you see that on the AP test, you're going to know now what they're doing. Oh, it's going to be a buffer problem. And you're going to probably be right. Okay, so 25 milliliters of HCl, if we add that, Ute. So, you can look back at part A to think about the chemicals. Remember, you're starting with an H3, and now I'm going to change this so Bella can see this too. If I had 25 milliliters of acid, and I had 50 milliliters of this stuff, I'm going to have half what? Ion and half what? What are my two chemicals other than the water? What are my chemicals that are going to be in there? I want more than one person to know. Alex?
Your chemicals would be HCl and
Now, I want to know once they get together, Alex, what I get. I'm going to have half of what and half of what? And Sophie?
You have half and think you have half of always moment.
H2O. No. H2O I don't care about. NH4. NH4 plus. Okay. So that didn't work out so well. Let's back up and bring everybody else along, okay? Maybe that was harder than I thought. Okay, so here's what that is. Think with me. I had NH3, right? Out of the HCl, what's the important thing out of there? The
The hydrogen, the A+.
H plus. And so now I'm going to make just what? Yeah. So now do you see why I'm saying what two things are in there? I've converted, what did I had? I had 50 of this, right? And I had 25 milliliters of this. Aren't I converting it? So now I got 25 left. Those are all used up and I got 25 of that. You know what I'm saying? So like the other time where this may, I hope, look familiar now, I've got half of a weak acid and half of its conjugate, which is a buffer. I really want you to sniff that out. Oh, okay. It's always going to be a buffer. Always going to be a buffer. Okay, so just do it. The pH equals, what's my handy dandy buffer equation? The pKa, super. Whoops, not really small. Well, is it B or
E minus.
over?
Concentration of E minus over.
Super. Good. All right. So let's do it. Here we go. So the pH is the pKa. Do I have the pKa somewhere from this sucker?
Yeah.
No, but I got the Ka somewhere. Look on the board.
Oh, yeah.
There you go. So can I take the negative log of that in the problem? Okay, negative log of 5.6. It's right over there. 6 times 10 to the negative 10. Plus, yeah, why? Because it's a 1 to. Now, if we wanted to like worry about it, I could come out here and say, well, again, it was 1 molar at the beginning, and now I've doubled the amount of liquid. What is the concentration of molar if I had to write it? Anthony? 0.5 molar, 0.5 molar, exactly. But as Aiden said, I could just say it's 1 to 1 and just do the log of 1, which you guys know is 0, right?
I have a question. If you know that it's a 1-to-1 ratio, you just not like ignore the fact that you have to add the log. Log of 1 to 0.
If it's multiple choice, don't even screw around with it. If it's a FRQ, write log of 1 to 1 just to let the grader know you know what you're doing. Okay. Okay, what do we get from the pH, folks? 1.3?
9.3.
Thank you. Super. I probably don't have time to do the last part. Here's the thing about this. What they're going to also do, and I'll try and remember to do this with the next time, is they're going to have a graph like this. And the bottom axis will be milliliters of acid added. And you're going to go to 25, and then you're going to go up, boom, and find the pH right there. So you can do this also from the graph. But you're going to take half the amount on the graph every time. Half the amount. Good. Thank you, folks. We'll see you live on Monday.
I dropped my for the yeah, 3 hours. Yeah. I guess I'm gonna record it. Okay. See you tomorrow.
Yeah.
Little buffer.
Yes, I love that. See, the field does have some buffer.
Yeah, I was wondering what the buffer.
I didn't try to
Ask Paul Ruben.
I looked at it and I was like, hey, chemistry, I learned about this today.
Or you can actually Google and ask. And I'm sure that actually helps you.
Yeah, I was really shocked because they said that that we're supposed to take saliva test, and then they gave us the
Is there a nose from? Oh, that's how they did it.
no, and they usually gave us like kind of so they have to do them.
All right, bye everybody.
Yeah.
Komplett vergessen. Wir machen das schnell.
Ja, das war. Wir müssen mal wieder anfangen, das Kilo zu stellen. Also,
Ja.
3 Tage durch. Also,
Genau. Ich bin außer Übung.
ich langsam auch durch. Was sonst alles gut?
Ja, ist okay. Es ist schön, die Schüler wieder zu sehen. Nicht nur zu Hause. Im Keller ist ja nicht so
Ich wäre mal
Spaß.
froh, wenn ich das mal nicht sehen würde.
Ja.
Wann jetzt nicht mehr?
Ja, die positiv sind, die können zu Hause bleiben.
Ja.
Und warst du schon geimpft oder noch nicht?
Ach, oh.
Nee, noch nicht.
Wo denn? Kommt da irgendwo an?
Ja.
Wir testen das.
Ja.
Aber also okay.
Ja. Ich habe eins gestern gemacht.
Ja. Gefahr.
Bye.